Hi everyone, good day and welcome back from SAMMAT. We are going to talk about quadratic function today, quadratic equation. I'm going to share about quadratic equation. So excuse my lightning, the lightning is not really good today, but I'm really want to talk about quadratic equation. So I'm going to talk about quadratic equation today. Okay, so we have known about linear equation in our past. We have talked about linear equations, okay? If you want to know more about linear equation, I'm going to do another video series about linear equation. But today we're going to talk about quadratic one. So we know the linear equation exists in the form of y equal to mx plus b, where m is like the slope of the line and b is like the constant here. And most of the time, this type of graph exists in the form of something like that. It could exit like that, it could be like that, it could be something like that, right? The graph could exist in the form of something like this. Okay, so this is the graph here. This is the example line that I'm talking about. And then today we're going to talk about quadratic equation. So our main talk is quadratic equation. So quadratic equation exists in the form of y equal is a function, okay? So I'm gonna write the equation first. The equation exists in the form of ax squared plus bx plus c equals 0, okay? It doesn't really matter, okay? We're gonna take a look at this part first. This part first, okay? So it's a polynomial. So these coefficients are like, these numbers are like the coefficient of this particular x, the particular power of x. A is like coefficient of x squared. B is like coefficient of x, and C is like in term of polynomial, we can think like C is like coefficient of x to the power of 0, which is 1. So which C became a constant here, right? So consider the equation exists in the form of this, but the important part of this is A cannot be equal 0. Because if A is becoming 0, the whole this part of the equation is becoming 0, and then our equation will be only exist in bx plus c part, so which is becoming linear, which is a linear equation, which doesn't really concern us in this quadratic world, because linear equation exists in the form of a straight line like that. It could be vary according to their like y-axis interaction, like how they intersect y-axis, and how much is the slopes. So it could vary in, it could be like anything at all. It is a straight line. But when it's come to quadratic equation, it exists in the form of, it exists in the form of like the graph that are like this. I might say it look like you. It could be like that. It could be vary according to, the number that we have been encountering. It could be like this. What I want to say is the ambiguity. Okay, ambiguous. It means like there is two eggs to number of x in any part of y. This is why we call it ambiguous. So what is interesting about this quadratic equation is it is always ambiguous because of the x square. Every a square number have two roots, right? A positive root and negative root. Because of the variation of having the positive negative roots, the quadratic equation is always becoming ambiguous. So when we put out the coefficient of a into 0, it became bx plus c. It is becoming linear, which doesn't have ambiguity at all. So a cannot always become 0. This is the first rule here. B can become 0, C can also become 0 because even is y the equation is like y equal to x squared or just x squared is still have ambiguous, right? Because uh, square always have ambiguous. It have positive and negative roots here. Okay, I don't really want to talk about more. We already understand it. We have handled it in our life. So quadratic equation is very significant in mathematics because it talk a lot more about the growth and its potentially. When we want to talk about population, we want to talk about economical growth, we can talk about lots of things using quadratic equation. I'm gonna explain a little bit more and later in the series about the use and application of quadratic equation, but we're gonna look at the basic structure of it in this video, okay? Okay, so let's go back to there. Quadratic equation exists in the form of ax squared bx plus c, and a is like the coefficient of x squared, b is like coefficient of x, and c is like coefficient of x to the power of 0. We can say c is a constant in here. Okay, so when we handle in quadratic equation, we can, of course, the most significant way to find the problem, the solution is by graphing it. But we're gonna go to the graphing later. But I'm gonna talk today three significant way we can solve quadratic equation. Number one is we call it factorization. Factorization. We're gonna factorize it, okay? So we can think of it like when it's come to less, I'm gonna explain it a little bit. When an equation start with an x squared and it might have something to do with it here. The idea of factorization is that we're gonna separate it into two part of the power with x. Okay, we're gonna separate it into two x. Some x might have a constant, some might doesn't have a constant at all. It doesn't really matter. If we can factorize it, this equation here like a squared plus bx plus c, and we're gonna separate it into an equation that exists, a form that exists in the form of h plus c, maybe h plus b. We can write it like that. And this product is becoming to this part, right? Coming back and forth. So we can factorize it and we solve the equation. So we're gonna name this method in the factorization method. Okay, I'm gonna explain further more. And then another method here we have is complete in square. Okay, complete in square. Okay, what is complete in square? So I'm gonna talk a little bit about it in the first, and as I said before, I'm gonna explain a little bit more detail or what is it in later. So complete in square is like inspired by the form of a quadratic equation that exists in the form of a plus b the whole square. Some equations tend to exist in this form, and in the method of complete in square, we just create this whole ax plus ax squared plus bh plus c into becoming this form. And we might add and subtract something and we're gonna calculate it. So completing square is also a method. So you can think of it like making a squared plus bh plus c into in the form of like maybe like is plus q the whole square, and we're gonna, maybe subtract or maybe like and add some number. It doesn't really matter. And this completing square is coming from the shapes of x plus q the whole square, which is very significant. And the third method is like the queen. Okay. And if we talk more about the third method, when it's come to calculation, we don't really use the first two method anymore. But sometimes it's just easier to use the first two method and the factorization, or sometime we're gonna use the second method. But the third method is the most significant one, which is called quadratic equation. Okay, we have know about this, right? Quadratic equation. Quadratic equation exists from this complete square, and we just made it into easier to use. I'm gonna explain it later, as I say before. But quadratic equation is like making this ax squared plus bx plus c. We just make it into like x equal to minus b plus or minus square root of b squared minus 4ac by 2a. I hope it is correct. So we just put it into the x into the formula, and we're gonna get to ambiguous answer, which is quite easy. We don't really have to do anything at all. If when we want to solve quadratic equation, we know this whole formula. We just have to use it. It's just quite easy. So in this video, I just want to share what is quadratic equation, and I have shared three methods that we can use to solve quadratic equation. So in later video, I'm going to explain a little bit more about how we can use each method and what is the difference between one method and another. And I'm going to explain a bit more about the graph and the application of quadratic equation for them both. So I don't want to make long video. I don't really like it. So I just have to stop this video for today, and there will be a series of quadratic equation, and I hope you guys will enjoy it. So this is all for today, and let's see the other day with another part. So this is the part one. Goodbye everyone, have a very nice day. And please, if you like or enjoyed this video, subscribe my YouTube channel. Bye bye everyone.